Okay, this is solving general trig equations for a trig or pre-calculus class. Uh, Pretty hard problems because it takes all your algebra, geometry, and trig skills and puts them all into play here. So I have tan of theta plus root 3 equals 0. Theta means degrees. I have a domain attached. Theta is an element of the set 0 to 360. Square bracket means inclusive of 0. Round bracket means non-inclusive. First thing I do here is I isolate my variable. So I'm going to subtract root 3 from both sides. Tan of theta is equal to negative root 3. That has to be a fraction, so it's over 1, where this is an opposite leg, this is an adjacent leg. I like this mnemonic device. All students take calculus, meaning that if I have a negative ratio of sides for tangent, it'll be in the second and fourth quadrants, positive in the first and third. So I draw out those triangles where my opposite is root 3 over negative 1, or down here where my opposite's negative root 3 over 1. These are 60 reference triangles. Then my general solution would be 120 plus 180n, but I only want values in this domain. So my solution is values 120 in the domain and 300 in the domain. So that's the first problem right there. Here's another problem, tan of x. So first thing I do when I see that x, I know I'm talking about radians, not degrees. This is number 9. And the domain x is an element of all real numbers, so I want a general solution. You cannot divide by tan of x because potentially you're dividing by 0. You got to subtract this from both sides. Subtract that from both sides of the equation. I have tan of x minus root 3 minus 2 tan of x equals 0. I have 1 tan of x minus 1 tan of x. So I have negative tan of x, negative 1 tan of x minus root 3 equals 0. I'm going to add root 3 to both sides. I'm going to add root 3 to both sides. It'll give me the positive root 3. Then I'm going to divide both sides by a negative 1 to get negative root 3 over 1. So negative ratio of sides. All students take calculus. It's here where my opposite is actually root 3 and my adjacent's negative 1. We're down here where my opposite's negative root 3 and my adjacent's 1. Again, 60 references, but I'm in x, so it's radian. I want all solutions, so my first value is 2 pi over 3 plus 360n, and then 5 pi over 3. But I could see also that this actually cycles every 180 degrees or pi, so I could just say 2 pi over 3 plus pi n. When n equals 1, that would give me my 5 pi over 3. So there's my solution to number 9. Key factor, x, I'm in radians. Domain is all solutions. Tangent is going to cycle every 180 degrees or pi degrees. And most importantly, don't divide by a variable in a function. Here's another problem. This one's hard to see. I have 2 secant squared of x minus 3 secant of x minus 2 equals 0. It's a quadratic. So if it's hard to see, I'm just going to turn it into an algebra 2 equation. 2x squared minus 3x minus 2 equals 0. If you saw that, you would factor it. Only factors are 2x squared or 2x and an x. Now the 2 either goes here or here. I think I'll put the 2 there first and try that. This is a negative, this is a positive. Let me double check that. 2x squared plus x minus 4x gives me negative 3x minus 2. So just like we did in algebra, I'm going to do the exact same thing on this trig equation. So I'm going to factor this equation here as 2 secant of x plus 1. And then this piece will be secant of x minus 2 equals 0. So on this, now I have 2 secant of x plus 1 equals 0, or secant of x minus 2 equals 0. Two things multiplied together equals 0. Either this equals 0, or this equals 0, or both do. I'm going to subtract 1 from both sides. So I have secant of x equals negative 1. Divide both sides by 2. So secant of x equals negative 1/2. What I'm saying here is my hypotenuse is 1. My adjacent is 2. That never happens. The hypotenuse is always the longest side, so this is an empty set. Right here, I'm going to add 2 to both sides. Secant of x equals 2. And it's the same thing. This is 2 over 1. This is ratio of sides. So what I'm really saying here is a hypotenuse is 2. The adjacent is 1. I can think of it as that way, or cosine of x equals 1/2. So secant and cosine correspond. All students take calculus. Positive ratio of sides is in the first or in the fourth. So I have those triangles, root 3 opposite, 60 reference. On number 14, my domain is x is an element of the values 0 to 2 pi. So I want this value, which is 1/3 of the way to pi. So x is equal to pi over 3 or 5 pi over 3. Those are the only two solutions in that given domain. X is radians. I discard these values as non-real solutions, and I only work with this. Just taking all your skills of Algebra 2 and combining it with trig and solving general trig equations. Okay, let me do one more problem here. General trig equation, tan squared of x minus secant of x minus 1 equals 0. With the domain, x is an element between negative pi and pi. A lot going on here. It's similar to the last one, but I have multiple arguments. If I have an equation with an x and a y, I need a second equation. And where I'm going to get that second equation is a trig identity. So I'm going to replace tangent squared of x with the Pythagorean identity, secant squared of x minus 1. So that's replaced with that. Then I have this secant of x. And now I have a single argument, all in terms of secant of x. I'm going to combine similar terms. That's this and this. So I have secant squared of x minus secant of x minus 2 equals 0. If I have a hard time factoring this, I could just look at an algebra equivalent. X squared minus x minus 2 equals 0. Factor that as x minus 2, x plus 1. We double check that. X squared minus 2x plus 1x gives me the negative 2. So I'm going to factor this the same way. Secant of x minus 2 times secant of x plus 1. Factored into two quantities being multiplied together equals 0. That means either this equals 0, secant of x minus 2 is equal to 0, or secant of x plus 1 is equal to 0. Add 2 to both sides. Secant of x is equal to 2. Well, 2 is the same as 2 over 1. It's reciprocal of cosine, so it's hypotenuse over adjacent. Positive ratio of sides in the first and the fourth, where my adjacent's 1. Hypotenuse is 2. We're down here. Hypotenuse is 2, adjacent's 1. Opposites root 3, 60 reference. So the general solution here is going to be pi over 3 and 5 pi over 3 plus 2 pi n. Don't forget our domain now, because we're going to cut it off there. On this side right here, I subtract 1 from both sides. Secant of x is equal to negative 1 over 1, where my hypotenuse is a 1 and my adjacent's a 1. My hypotenuse is a 1 and my adjacent is a 1. That's going to happen here and here. But this is 1 over 1 and I have negative 1. So it's negative 1 over 1. So it's only going to happen at pi. So this solution is pi and 2 pi there afterwards. Now I look at my domain for values between negative pi and pi, inclusive of negative pi, but non-inclusive of pi. So my domain right here, x is an element of the values between negative pi and pi, not including pi. So I could get to this triangle by going negative pi, so that's a solution, but pi will not be because of the rounded bracket. Over here, I could go pi over 3, that'll work, and also negative pi over 3 would work. So we're actually going to put these in order. Negative pi over 3, pi over 3, negative pi. So there's my solution given that domain. That was number 17.